Hello everyone, today I'm gonna talk a little bit about groundwater modeling, from equations to dancing graphics. As an example, I will use my project to know what's going on about groundwater models. Okay, so my study field is located at the north of Quebec City. It's a small catchment in Montmorency. It's a part of the experimental catchment BREF. And there we have a lot of instruments measuring different variables of the water cycle. For example, here we're measuring stream flow, we're measuring the groundwater levels, precipitation, evapotranspiration, and many other variables. Okay, so how to build a groundwater model? So first we have to define the purpose. In my case, I'm interested in study groundwater recharge. So I need to define how much is entering in the aquifers by different methodologies and using a model. Then we have to build a model, a conceptual model, so that is to describe the relationship between different variables on surface and subsurface. Then we have to select a code that is a model. In my case, I'm using a hydrogeological model. It's a coupled model. That means that it can contain the groundwater system and the surface system in one only model. So then we have to create the model, to design the model. And to do that, we have to define what is the area, what is the boundary condition, what are the properties, and define different zones of the aquifers, and so on. Then we have to calibrate that model. That is a really challenge. Calibrate is to match the model outputs of my model and we compare with my observed data. That is the data that we're measuring in the field. And we can do that manually or using automatic tools like PES. And finally, I have to do forecasts. We don't use the term prediction because forecast considers the unknown, the uncertainty associated with we're measuring, and those I will use different scenario of climate change to that predictions. Okay, thanks for your attention.